As mentioned in the previous video, I'll be starting by talking about exception handling. I've created a new project called File Exceptions. I'll create a variable for a file name, which I'll just assign a string literal to, testing.csv. Next, using the file name as an argument, I'm going to get a path instance with the help of a static method called get on a helper class called paths. Right now, I don't want you to worry too much about what these types are or how they work. I'll be covering them in detail shortly. After I have a path instance, I can call the static method readAllLines on the files class, passing it the path instance to get an array of string, which would be all the lines in the file. Again, I'll be getting into how this all works shortly, but what I want you to see is that this last statement doesn't compile. If I hover over that error, I'll see the message unhandled exception java.io.io exception. The IO exception is a special kind of exception called a checked exception. It's the parent class of many common exceptions you'll encounter when working with external resources. A checked exception represents an anticipated or common problem that might occur. You can imagine that a typo in the file name might be a common mistake, resulting in the system being unable to locate the file. It's so common that Java has a named exception just for that situation, the file not found exception, which is a subclass of IO exception. How do you handle a checked exception? You have two options. You can wrap the statement that throws a checked exception in a try-catch block and then handle the situation in the catch block. Or alternately, you can change the method signature, declaring a throws clause and specifying this exception type. Let's see what both of these options look like in code. If I again hover over that error, you'll see IntelliJ is prompting me with one choice there on the left, add exception to method signature. I will choose that. And IntelliJ had added a throws clause to the main method. If this weren't the main method, this might make sense, but having the application throw an exception and close down isn't the most user-friendly solution. I'm going to undo that and pick a different option, this time selecting more actions on the right side of this dialog. This lists two options at the top. The first one is what we already tried. I'll select the surround with try catch option. Let's see what happens if I run the code this way. I get a runtime exception wrapped around another exception, no such file exception, because this file doesn't yet exist. This way of handling the exception was not to handle the problem at all and not to force the calling code to handle it either. It did inform the user and quit out of the application. It might be true that this is a fatal mistake and that this file, testing.csv, may really have to exist for the application to run. Another approach might be to check if the file exists in the first place. I'll comment out the try-catch block here for now. Now I'm going to use another class to work with our testing.csv file. This is the file class. In this case, I can create a new file instance using the constructor on this class that takes a file name. This class has a method called exists that will test if the file exists. If it doesn't exist, I'll print a suitable error message and return from the function. This effectively closes the application. If the file exists, I'll print the message, I'm good to go. In this case, I'm first checking if an error situation exists. In the previous example, the code simply assumed that the file would exist and threw an exception when it couldn't find the file. These two different approaches have the acronyms LBYL and EAFP. LBYL stands for Look Before You Leap. This style of coding involves checking for errors before you perform an operation. EAFP stands for Easier to Ask Forgiveness Than Permission. This assumes an operation will usually succeed and then handles any errors that occur if they do occur. Which approach is better? Like all questions about software, the answer is, that depends. If errors are rare, you might want to use a look before you leap, but it does make the code more verbose. If errors are unexpected rather than the garden variety type, the easier to ask for forgiveness than permission approach might make it more difficult to debug. You can see from my code that both of these ways of dealing with a checked exception had the same effect. In both cases, the application was terminated because of this condition. How do you recognize a checked exception? When you're coding with an IDE, it's pretty easy to recognize one because your code won't compile if one is thrown from code you're calling. If you're taking the certification exam, you can remember that a checked exception means it's not an unchecked exception. An unchecked exception is an instance of a runtime exception or one of its subclasses. Let me just pull runtime exception up in the API documentation. Here you can see a long list of runtime or unchecked exceptions. Some of these you're probably pretty familiar with by now, such as index out of bounds exception, null pointer exception, and so on. If your code throws any of these exception types, it's up to you whether to anticipate these using either the LBYL or EAFP approaches. If you don't do anything, the exception will propagate up the call stack looking for code to handle it. This means that the exception is passed from the method where it was thrown, exiting that method at the point it occurred. It's pushed back to the method that called it, and so on, until it reaches the top of the call stack, which is usually the main method. If the exception isn't handled by any methods on the call stack, it terminates your program with an exception stack trace, as you've seen countless times in this course and a few times in this video. In general, any code in your code block that comes after the statement that threw an exception isn't going to be executed. But there's one exception to this, no pun intended. The try clause has an additional clause called the finally clause. Any code in the finally clause will get executed, whether an exception occurs or not. Let me set this up. First, I'll uncomment the try-catch block of code. Next, I want to create a private static method that returns void, and I'll call it test file with one parameter, a string called filename. I'll cut the code that has the path variable statement and that try-catch block from the main method and paste it into the new method. Next, I'll just add a statement at the end of this method that says file exists and able to use as a resource. I'll pop back up, and where I had the try-catch block in the main method, I'll instead make a call to this method. If I run this code to see what happens, I get an exception as I did before, with one difference. Notice the stack trace here. You can see that the exception occurred in the test file method, and because it wasn't handled there, it propagated up to the main method which called it. Here again, the exception's not handled, so the program exits ungracefully. The statement at the end of the test file method was never printed. As I said previously, any code after where the exception occurred isn't going to get executed. That is, unless it's in a finally clause. I'll include a finally clause in this try-catch statement of the test file method so you can see how that works. I'll add finally after the catch clause. I'll print out, maybe I'd log something either way. A finally clause doesn't have any parameters like the catch clause. Let's review what that gives us. You can see that maybe I'd log something either way was printed. Whether an exception occurs or not, this code in the finally clause will be executed. In this case, we were expecting an error and wrapped our statement in a try clause. I'm not really handling it, but I'm masking it as a runtime exception and throwing it in the catch clause. Before that gets thrown and execution returns to the main method, the code in the finally clause gets executed as you just saw. A finally clause is used in conjunction with a try statement. A traditional try statement requires either a catch or a finally clause or can include both. The finally clause is always declared after the catch block if one is declared. The finally block's code is always executed regardless of what happens in the try or catch blocks. The finally block does not have access to either the try or catch block's local variables. The original purpose for the finally clause was to have a single block of code to perform cleanup operations. This included closing open connections, releasing locks, and/or freeing up resources. This clause ensured that this code was executed, both during normal completion as well as in the event of an exception. The try with resources syntax introduced in JDK 7 is a better approach than using the finally clause for closing resources, which I'll cover shortly. The finally clause can be used to execute other important tasks, such as logging or updating the user interface. The finally clause has some disadvantages. It can be difficult to read and understand code that uses this clause. It can be used to hide errors, which can make debugging more difficult. If you execute code that's not related to cleanup tasks, this will make it harder to maintain your code. Okay, so getting back to the code, Let me just cover a couple of these points. First, I'll comment out the catch statement. Now I'm back with a checked exception problem because I'm not handling the possible I/O exception. I'll add it to the method signature for a moment just to get rid of that error. Now you can see that this code compiles, but I've pushed the problem up to the main method on the call to this method. Since I didn't handle it in my method, any code that calls this method must now either have to catch this exception or specify it in the throws clause. I'll again choose to add it to the main method signature. Running this code, you can see that I again get the message, maybe I'd log something either way. This demonstrates that you can have a try statement with just a finally clause. I'm going to undo those last changes, first removing throws I/O exception from main, and next removing throws I/O exception from the test file method, and finally undoing the comments, putting back the catch clause in the test file method. Now in that catch clause, I'm going to force another error. I'll replace the throw new runtime exception and then just purposely code a divide by 0 exception there. Now here, an exception is definitely occurring, but it's going to happen in the catch clause itself while it's trying to handle a previous exception. What happens if I run this? Well, you can see I still get the statement printed from the finally clause, but the exception that got thrown was actually an arithmetic exception, so the last exception that occurred. This means that if you get an exception in your try block or your catch block, the code in the finally clause still executes. I'll undo that last change. If my finally block code gets an exception, however, then I'm out of luck, and execution will end at that point. Okay, I'm going to bring this video to a close here. In the next video, I'll pick up from this point but show you the alternative version of the try statement, which is the try with resources statement. See you in the next video.